This is question number 2, section 10.3. The college entrance exam company determined that the score of 23 on the mathematics portion of exam suggests the student is ready for college level mathematics. To achieve this goal, the company recommends that the students take a core curriculum of math courses. Suppose the random sample. Suppose a random sample of 200 students, so the sample size is 200 students, who completed his course set of courses resulted in the mean math score of 23.3. So for the sample, the mean is coming 23.3. On the college entrance exam with standard deviation S for the sample is 3.08. Do these results suggest that students who completed the core curriculum are ready for college level mathematics? Who is ready for college level mathematics? Who scored 23, determined that a score of 23 uh, has to be there. Like, so minimum is 23. So they have to increase it from that, right? So alternate hypothesis and the null hypothesis we have to write. The original would be, it's about mean, so original mean is 23. We are testing if after doing the course, the core course, it has increased from 23. So let's see if that is correct. Our null hypothesis is mu, that is always equal to, so this would be 23. Alternate hypothesis is also based upon mu, and the alternate hypothesis will be mu is more than 23. Check. Okay. Verify the requirements. What are the requirements? Now the sample size is 200, so that is more than 30. So we do not need to check normality. Okay. The sample size is larger than 30. The students are randomly selected. I think it's mentioned in the question only. Suppose a random sample, here it's written. So we are good with that. And the last one, the sample comes from it's not mentioned that it is coming from a normal, so we do not have to check that. The student test scores were independent of one another. Of course, they one student score does not affect other student score, right? So these are the three conditions. Okay, now use the p-value approach at alpha equal to 0.10 level of significance to test the hypothesis in part A. Identify the test statistics. So let's note down our, so if all that is correct, for the sample mean one proportion, one population, you need to use t-test. It's here in stat test. We have stats given to you. So highlight stats here. The mean is 23, the original mean. The sample mean is 23.3. Standard deviation is 3.8. And the sample size is 200, and we are into more than type, so highlight that and then press calculate. So this is your t here in the calculator is your test statistic t naught. So you need to round it to two decimal places. 1.12, that's the test statistic. You also need p-value rounded to the 3 digits. P-value is here. So it p when the calculator, so you enter that 0.133 rounded to 3 places. Okay, what does it say now? Write the conclusion based upon the results. So let's see what the conclusions are, right? So what's happening here? Let's draw a little diagram of the t distribution. Okay, first of all, p-value is equal to 0.133, alpha is 0.10, p-value is more than alpha. So we are gonna say do not reject H naught, because that is the test, right? Based upon test statistic, so we have our test statistic 1.12 and our Because of the H1 here, we have right-tailed test. So that means our critical region would be, extreme would be in the right side. This is my critical region. How do I identify that? For the critical region or the rejection region, you need to find this T critical value. As we are in the right hand side, that means all the alpha is going into the right hand side. So this value here should be T alpha. Alpha is 0.10. So that means T 0.10. What is degrees of freedom? Degrees of freedom is n minus 1. N is 200 minus 1. That's 199. So when you see your column formula chart, here it is. You need to find the degrees of freedom for 199. Now, 199 is not there, right? So if it is more than 100, you just consider it to be the closest number to the 199. Where will be the closest number? Say 100. Let's say that. And 0.10 is this fourth column, 1.290. So critical region value T alpha is 1.290, and our T statistic we found to be 1.11. So we'll see where this is. 1.11 is here somewhere. That is your T statistic, right? That means that T statistic is not lying in the rejection region. T statistic is not in rejection region or critical region. That means we do not reject H naught based upon T statistic also. So what is happening in the conclusion? We are not rejecting H naught. So that means we are rejecting H1. We do not have sufficient evidence of student score increasing. Let's see what it says. Conclusion is do not reject null hypothesis. Claim that there is not sufficient evidence to conclude that population mean is more. So the first portion is your decision, that is based upon null hypothesis. The second portion is always based upon the claim. If you are not rejecting null hypothesis, that means you're rejecting the alternate hypothesis. So your claim will not have sufficient evidence. What was the alternate hypothesis? That the score is more than 23. So that doesn't have enough evidence.